So in the previous video, we saw how to find out the displacement at any point at a distance of x using the shape functions. So n1 and n2 are shape functions. Okay, now let us use generalized coordinates. And in this approach, what we do is the polynomials with number of constants which are equal to the nodal degree of freedom are selected. So if we take one bar element, 1, 2, two nodes are there. Okay, so this is a one dimensional element, so the degree of freedom will be 2. Okay, so as I said, the number of constants should be also equal to the degree of freedom, number of constants. The generalized coordinates are denoted by alpha 1 and alpha 2. These are generalized coordinates. Okay, so let us begin with this. This is at a distance of x1 and this is at a distance of x2. The displacements here are q1 and q2. The displacement u at any point is given as alpha 1 plus alpha 2 x. Okay, and this is the general form. Now if I want to write this for the displacement at node 1, it will be q1 equals to alpha 1 plus alpha 2 x. q2 will be equal to, this is x1, alpha 1 plus alpha 2 x2. And let me call it equation 3. Now if I want to write this in a matrix form, it would be q1, q2. Okay, in the vector we will write the terms which are common in both these equations. What is common in both these equations is alpha 1 and alpha 2. So when we multiply this matrix with this vector, we should get these two equations. I want to find out what the constants are, that is what is alpha 1 and alpha 2. So this becomes inverse, the matrix becomes inverse. Okay, and the inverse of a matrix is given by 1 upon determinant of the matrix. Okay, so say we have A and we need to find out A inverse. So A inverse is given as 1 upon determinant of A. Okay, and multiplied by the just a minute, it has to be multiplied by transpose of the cofactor matrix. Okay, so determinant of A will be 1 into x2, which is x2, minus 1 into x1, which is x1. Okay, now the cofactor, this is how we find out the cofactor. So to find out the cofactor of the first row and first column, I have to cover this and this. Okay, so it is x2 what remains. Okay, so the cofactor of this place is x2. I request you all to revise cofactor and transpose and all these things. Okay, so it has to be plus minus minus plus. So the cofactor of this place here will be minus 1, sorry, minus 1. Cofactor of this place will be minus 1. Minus 1. This place will be minus x1 and 1. So it has to be transpose of this q1 q2 x2 minus x1. Transpose is nothing but interchanging the rows and the columns. q1 q2. Okay, now writing this equation 1 in matrix form, equation 1. Okay, so we had alpha 1 plus alpha 2x. Okay, so we'll label this equation as 4. So I will be substituting this value of alpha 1 and alpha 2 in this current equation 4. So we have 1 x 1 upon x2 minus x1 the x matrix and the displacement matrix q1 and q2. Rearranging the terms, let us now multiply these two matrices. We will get 1 upon x2 minus x1. So it is this row matrix into this 2 by 2 matrix. So it is x2 minus x and minus x1 plus x into q1 q2. U can be given as x2 minus x upon x2 minus x1 and I'll just rearrange this x minus x1 upon x2 minus x1 multiplied by q1 q2. So we arrive at the same equation, that is, if you compare it with the previous lecture that we had, this is nothing but the term n1 and this is n2, the shape functions. So we have n1 n2 multiplied by q1 q2. This will be nothing but of the form equation of the form n1 n2 plus n1 q1 plus n2 q2. So this was obtained using generalized coordinates alpha 1 and alpha 2. Thank you.